Till now we completed the periodic motion, oscillatory motion, period and frequency, displacement and amplitude of the oscillatory body, angular frequency. Now it is time to learn about simple harmonic motion, the definition of simple harmonic motion. Okay, so definition of simple harmonic motion. You heard about the acceleration of the particle. See, this is said in 11th point. I take it first. Okay, so maximum and minimum values. Let us learn this one first. I said something about the displacement. The particle is making the oscillation about the main position in the horizontal direction. So at that moment, the displacement is said in terms of x. Okay, so when the particle at the extreme position, we will take it as the amplitude. So meantime at the leftmost end, it is x is equals minus a. If the particle is oscillating in vertical direction, so this will be the mean position, then y we take and that y becomes 0. When the particle is at some intermediate position, that displacement is y measured from the origin. Okay, so this height, that is y. When the particle is again at the extreme position, we will take it as say some plus a, and here if it is, then it is y equal to minus a. If the particle is moving in a two dimension, then definitely we have to consider both the displacements like x and y. That becomes a circular motion. Okay, so that is why we have treated equivalent to circular motion. Before that, we have to learn about acceleration of the particle in simple harmonic motion. Okay, so any motion kind of motion is said simple harmonic only if its acceleration is proportional to the displacement and towards a fixed point. See the definition of simple harmonic motion. So any motion is said simple harmonic only if its acceleration is proportional to the displacement and towards a fixed point. Okay, so the exact meaning is I'm going to explain, but how you can write it mathematically? If the motion is horizontal like this one, okay, so this is a horizontal, right? Horizontal, and this one is vertical. In both the cases, we can say the acceleration a so is proportional to minus x in case of horizontal displacements and a proportional to minus y in case of vertical displacements. So we are treating x a proportional to x because it's a indefinition. It is said the acceleration is proportional to the displacement and it is acting towards a point, right? So the meaning is putting a negative. Mathematically, this negative sign says a and x are in opposite direction. At any point, if displacement is acting in this direction, then acceleration is acting in this direction. This is the meaning of saying the negative sign in the expression. Okay, these are vector quantities. This is how we express the vector quantities. Okay, More simply, we write it a proportional to minus x. Here we add one more term, that is further what we can do is further a is equal to minus omega square x. This is what we can prove next. Okay, or here what I can write, a is equal to minus omega square y. This is the way how we express the acceleration of the simple harmonic motion in terms of displacements. Okay, in terms of displacements. So you have to memorize these equations, these results, in order to understand the further concepts. At extreme edges, what happens? X becomes plus a and x becomes minus a. You can treat any one. Okay, so we shall treat to the right side one. Okay, so right side one, that is x equal to a. If I take x is equals to a, that is plus a. Okay, this is the maximum possible displacement. Maximum possible displacement. The body cannot go beyond this, right? So it is not going beyond this point. So x is equals to a is the maximum displacement that is possible. So at that moment, when I put the value of x in the above equation, what I may get, a is equal to, right, minus omega square a. And a is the maximum possible displacement, that is x, right? So at that moment, I can simply say this value of a is also maximum. So now what we are seeing is the expression for maximum acceleration in a simple harmonic motion. Meantime, here also I can write the same. So a maximum is equal to minus omega square x. Now look here. So both are appearing same. Okay. But this amplitude is along x-axis and this amplitude is along y-axis. That's the difference. Right. So now you learned the definition of simple harmonic motion. The 11th point, which is acceleration of the particle in simple harmonic motion, where it can assume maximum and minimum values. So yeah, of course. So minimum value means what? Minimum value means what? See, at the midpoint, that is this one, right? At the midpoint or mean position, we can say the value of x is what? Value of x is 0. That is the minimum value of x. Okay. So now I write one more thing here. If x is equals 0, this is minimum displacement, right? Minimum value of displacement. Minimum value of displacement. So what do we get? This happens at a mean position, right? At a mean position. At mean position. What we say? So when I put this one in this expression, then what I can write? A is equal to minus omega square into 0. Otherwise, simply a becomes 0. Right? This is the minimum value of acceleration. This is possible at mean position. Meantime, on this side also I can put the same thing. If y equal to 0, so right, y equal to 0, then a minimum is again 0. Right. So this is how we have to understand the minimum value of the acceleration of the particle in simple harmonic motion.